All right, this is the last example in the notes. Apologize for not getting to it in class. Solve the following system of linear equations using Gaussian elimination. All right. So we got to put it into row echelon form. So here's the augmented matrix. 1, 1, negative 10, 4. Negative 1, 0, it's a good start. Positive 7, 5. Negative 3, negative 5, 36, oh geez, and 10. All right, so I'm going to eliminate these two entries first to get them to 0. To do that, I'm going to take row 1 plus row 2, store it into row 2, and 3 times row 1 plus row 3, store it into row 3. Row 1 stays the same. The others are going to change. So that's 0, 1, negative 3, and 9. And then 3 times that, 0, negative 2, negative 30 plus 36 is 6, 12 plus 10 is 24. I'm going to take half of row 3, clean that up just a wee bit. So multiply by negative 2, that makes it 1, negative 3, negative 12. I think I made a mistake. Geez, this is a negative 4. This is a problem with matrices, people. Start it all over. So last example in the notes asks us to solve this equation using Gaussian elimination. So that means put it into row echelon form. So here's the augmented matrix. 1, 1, negative 10, negative 4. Negative 1, 0, 7, 5, negative 3, negative 5, 36, and 10. All right, so I'm going to get rid of these two entries first. I'm going to do two operations on this at the same time. I'm going to take row 1 plus row 2, store it into row 2, and 3 times row 1 plus row 3, and store it into row 3. I have room to do one more here. First row stays the same. Second row, just add them together. 0, 1, negative 3, 1. Last row is 3 times, that's 0. 3 minus 5 is negative 2. Negative 30 plus 36 is 6. Negative 12 plus 10 is negative 2. Let's take negative 1/2 of row 3 to clean up that clean up that equation on the bottom a little bit. You should kind of see that something's going on here. These two equations are exactly the same. I'm going to finish it though, just to show you kind of what it's supposed to look like here whenever you have this type of solution. I'm going to take negative row 2 plus row 3, store it into row 3. 1, 1, negative 10, negative 4. 0, 1, negative 3, 1. So 0, negative 1, it's basically going to 0 out that last row. So then if we just convert it back into our regular system, this is x plus y minus 10z equals negative 4, and y minus 3z equals 1, and 0 equals 0. And this 0 equals 0, basically, remember when we were solving them by hand in the last, whenever the variables disappear and you get a true equation, it means you have infinitely many solutions. So these are going to be 3 planes in 3 space that intersect on a line. So we got to find a way to express the infinite solution set. So if you remember, we solved one of the variables, solve something for one of the variables, solve one equation for one of the variables. That's 3z plus 1. So we got my x, my y, and my z. I'm going to let z equals t. And then y is going to be 3t plus 1. So that's y in terms of t. Now I got to get x in terms of t. So x is equal to, I'm just getting this one right here. That's equal to negative y minus plus 10z minus 4. Negative, but y is 3t plus 1 plus 10, and the z is t. So that's negative 3t minus 1 plus 10t minus 4. So x is equal to 7t. Oh, it's getting a little sloppy there. Sorry about that, guys. Minus 4. Negative 3t minus 1 plus 10t minus 4 minus 5. So my solution is 7t plus minus 5, comma, 3t plus 1, comma, t. And if you want to get fancy, you can say for t and a set of all real numbers. But no, you don't need to.